Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question paper because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exam. So today, students, we will be solving JEE 2023 6th April shift second paper. JEE 2023 6th April shift second paper. In this particular video, I will be solving physics part of the paper. So here we go. So the very first question, that is question number 31. It says that the temperature of an ideal gas is increased from 200 Kelvin to 800 Kelvin. If RMS speed of a gas at 200 Kelvin is V0, then RMS speed of the gas at 800 Kelvin will be. So students, this question is from the chapter of kinetic theory of gases. This question has been asked so many times in the previous exams. So this question is hell lot important. Along with the RMS speed, we must know other formulas also. Okay. So there are three main formulas from which the questions are used to be asked. The first formula is for the average speed of gas. So the formula for the average speed of gas is under root of 8 kBT over pi m, where T is the temperature, m is the mass, and kb is the Boltzmann's constant, whose value is 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. And the second formula is for VRMS. This question is basically for the VRMS. Root means square value of the gas. So its formula is 3 kBT over m. Okay. And the third formula is VMP. VMP means most probable speed of the gas. And its formula is under root 2 kBT over m. So among of these three formulas, this question is asking about the RMS speed. So we are using here this formula, that is VRMS is equals to under root 3 kBT over m. Okay. So this question says that the temperature of an ideal gas is increased from 200 Kelvin to 800 Kelvin. So temperature is increasing from 200 to 800. Okay. We have to find the RMS speed of the gas at given that the RMS speed of the gas at 200 Kelvin is V0. So at 200 Kelvin, the RMS speed is V0. So we have to find it at 800 Kelvin. Okay. So students, here you are seeing that Kb is constant, 3 is constant, mass is constant. So VRMS is basically directly proportional to temperature. Okay. When the temperature is 200 Kelvin, its velocity means VRMS is V0. So V0 equals to 200 Kelvin. Okay. Here you see that the temperature is increasing from 200 to 800 Kelvin, means 4 times. 200 is increasing from 200 to 800, means temperature is increasing 4 times. If temperature is increasing 4 times, then the speed must be increasing by, since V is directly proportional to temperature T. So if temperature is increasing by 4 times, so the speed V naught must be increasing by 2 times 2 V naught. So our correct answer is 2 V naught. Okay, since how 2 V naught? Since under root of 4 is 2. So if the temperature is increasing 4 times, the velocity speed of the gas is increasing by 2 times. Got it? Okay, so the correct answer is B, 2V naught. Okay, now moving towards our next question, question number 32. This question says that given below are two statements, one is labeled as assertion A and the other is labeled as reason R. What assertion A says? The phase difference of two light wave change if they travel through different media having same thickness but different indices of refraction. Means this question is from the light part, okay, light chapter optics part. So if it's saying that the phase difference of two light wave change if they travel through different media having same thickness but different indices. Means there are two media, medium 1, medium 2, medium 1, medium 2, and light ray, this is normal light, in this is incident light, this is refracted light, this is incident light, this is refracted light. If these two media, means medium 1, if medium 2, if these two media having different uh having same thickness, okay, if these two media are having same thickness but the refractive index is different, means mu1 and mu2 are not equal, they are different, okay. So the reason, so they must be having change in phase difference, okay. Means what it is saying, if there are two media, medium 1 and medium 2, and light is traveling from medium 1 to medium 2, okay, and the thickness of these two medium, means medium 1 and medium 2 are having same thicknesses but their refractive index are different, means mu1 is not equal to mu2, then they suffers a change in their phase, means they are having a different phase. Or and the reason given for this is that the wavelength of the waves are different in different media. Its reason, the reason behind their phase difference is given as he, they have different wavelengths, okay. Means in medium 1, lambda 1 is different from lambda 2, okay. Since mu1 is not equal to mu2, so the reason is that lambda 1 is not equal to lambda 2. So we have to see, is this the reason is correct? Okay. So we know that the speed of light in a medium is given by V equals to C over mu, where C is the speed of light and mu is the refractive index. This V, speed of light, this V can be written as frequency into lambda equals to C over mu. So here we see that this lambda is directly proportional to 1 over mu. So as mu is changing, lambda is also changing, okay. And when light will travel through two different mediums, means when light is traveling from medium 1 to medium 2, their phase difference will change. The phase difference is given by del q is equals to 2 pi over lambda into delta x. Means if if mu is changing, lambda is changing. If lambda is changing, so phase difference is also changing. So this reason is correct for this assertion. So the correct answer is option A. Both A and R are correct, and R is the correct explanation of A. Got it? Yeah. So moving towards our next question. This question says that for an amplitude modulated wave, the minimum amplitude is 3 volt. Okay. While the modulation index is 60%. The maximum amplitude of the modulated wave is. This question is from the chapter. Which chapter? Communication chapter. Okay. This question is asked from the communication chapter. So we know that the modulation index mu is equals to A maximum, means maximum amplitude minus A minimum, minimum amplitude over A maximum plus A minimum. Okay. So here we are given 60%. So mu is given as 60%. Okay. So 60% means 60 over 100 equals to, we have to find the maximum amplitude. So maximum amplitude is x minus A minimum is 3 over A maximum is x plus A minimum is 3. Now solving this question as cross multiplying 60 x plus 3 equals to 100 x minus 3. This will be 60x 180 equals to 100x minus 300. Okay. So this will be 60x minus 100x minus 300 minus of 180. So it will be minus of 40x minus of 480, cancelling minus 0, x will be 12. So our answer is x equals to 12. So the correct option is B, 12 volt. Got it? Now, next question, question number 34. This question says that the ratio of speed of sound in hydrogen gas to the speed of sound in oxygen gas at the same temperature is. This question is basically from the chapter, which chapter? Kinetic theory of gases. Kinetic theory of gases. So this question says that the ratio of speed of sound in hydrogen gas to the speed of sound in oxygen gas. Hydrogen gas to oxygen gas. Okay. First of all, we should know the formula for finding the speed. Its formula is equals to V equals to gamma RT over M, where gamma is the adiabatic constant. Adiabatic constant. Okay. And R is the gas constant, T is the temperature, and M is the mass. So these two are diatomic molecules. S2 is also diatomic molecule and O2 is also diatomic. So for diatomic molecule, the adiabatic constant will be same for both. Gas constant will be same. Temperature T will be same. So it basically depends on 1 over m, mass, under root of 1 over m. So first of all, we should know what is adiabatic constant. This adiabatic constant equals to ratio of these two specific heat, means specific heat as constant pressure over specific heat at constant volume, and its formula is equals to 1 plus 2 over n. Okay. For general information, this n is equals to 3 for monoatomic gas, n is equals to 5 for diatomic gas, and n equals to 6 for triatomic gas. If the question is not like this, means here the both are diatomic gases. Okay. If instead of these diatomic gases, one is monoatomic and other is diatomic, then this speed is will also depend on the adiabatic constant gamma. Okay. For this, we will find the gamma for monatomic. So from this, the gamma for monatomic will be 1 plus 2 by 3. For diatomic, it will be 1 plus 2 by 5, and for triatomic it will be gamma plus 1 plus 2 upon 6. Got it? So here, since both two gases are diatomic gases, so this gamma will be same for both. So when we neglecting this and this, it basically depends on 1 under root of 1 over m. Okay. So V of S2 over V of O2 is equals to under root of mass of O2 over mass of S2. Okay. So mass of O2 ka mass 32 over mass of hydrogen 2. Since they are diatomic gas, 16 into 2, 32. And for hydrogen, 1 into 2, 2. Okay. So it will become under root 16 over 1, which is equals to 4:1. So the correct answer is D, option D, 4:1. Got it? Okay, now moving towards our next question, that is question number 35. This question says that a dipole comprises of two charged particles of identical magnitude q and opposite in nature. The mass m of the positive charge particle is half of the mass of the negative charge particle. The two charges are separated by distance L. If the dipole is placed in a uniform electric field E in such a way that dipole axis makes a very small angle with the electric field E, the angular frequency of the oscillation of dipole when released is given by. We have to find the angular frequency omega. Okay. So this question is basically from the electromagnetic waves part, okay? From the torque part, or you can say. Okay. So now we are solving this question. Torque part means this is basically from the chapter rotational motion. Got it? Now, solving this question. So, this question is asking as, see, let us first understand the scenario of this question, okay? So, according to this question, there are a dipole. Okay? So, we know that a dipole, formula for dipole is 2ql. 2ql means the dipole is comprises of two charges having same magnitude but different direction. Okay, one will be positive and another will be negative. So let us understand this question as, see, suppose there is a uniform electric field. Okay, in this electric field there is a dipole having charges q and q. One is positive and another is negative. Okay, suppose the force is F equals to QE is acting in this direction due to this positive charge, and F equals to Q is acting in this direction due to this negative charge. Okay, and the masses are given as M and half of the mass of the negative charge. Okay, suppose its mass is M and its mass is M by 2. Got it? Since it is in a uniform electric field, E is in this direction, so it will comprises of a torque and it will tend to move in its this direction. So this will do SHM in its direction. So this will tends to be in its original position and it will do a rotation motion around the center of mass. Let us say its center of mass is here. Why it is here? Because this is mass m, this is mass m by 2. So the center of mass is always towards the heavier mass. So its center of mass is here. And since the masses are in ratio 1 by 2, so the length will be divided in the ratio 2:1. So its length will be 2L by 3 and its length will be L by 3. Got it? Okay, now we have to find the angular frequency omega. Okay, so the formula for torque tau is equals to I moment of inertia into alpha. Okay, this torque tau will be equals to force into length F into L. So for C, for this L, this length, this L will be how much? L by 3 sine theta. And for this length will be 2L by 3 sine theta. Okay. 2 sine theta into L. Okay, got it. So for this tau, we can write QE charge into this L by 3 sine theta plus QE into 2L by 3 sine theta. it will be equals to I into alpha. Okay. Now adding both these two, QE L by 3 sine theta will be common. 1 plus 2 equals to I alpha. Since this theta angle is very small, so for small theta, we write sine theta is equivalent to theta. So this will become QE L by 3 into 3 theta. 3 cancels out each other. So this will be equals to QE L theta equals to I alpha. Okay, this is equation 1. Now I moment of inertia will be equals to mr square, adding mr square of both, so it will be equals to m into r square. Okay, r square means L by 3 square means L square over 9 plus mr square means m into 2L by 3 whole square. This will become ml square over 9 plus m 4L square over 9. Okay, so this will become ml square over 9, 1 plus 4, it will be equals to 5 ml square over 9. Okay, so this QEL theta will be equals to 5 ml square over 9 into alpha, cancelling L. We get alpha is equals to 9 over 5 ml q into E. Now this alpha is omega square. It will be 9 QE over ml square angular frequency. So omega will be equals to how much? Under root of 9 QE over 5 ml. So this will be equals to how much? So it is m by 2, okay? It is m by 2, so it will be 4 by 2, 2 plus 1, 3. Oh, ml square over 9 plus m by 2, 4L square over 9, 2, 2, 4. So it will be 1 plus 2, okay? 2 plus 1, 3. 3ml square over 9. Wait. Something is missing here. Something is missing. It will be m by 2. Okay, so it will become, wait a minute. It will become ml square over 9 plus m by 2 into 4L square over 9. Now it's correct. So it will be equals to ml square over 9, 1 plus 2, 3. Okay, it's correct. So it will be 3 ml square over 9, ml square over 3. It will be ml square over 3, 3, 3. So it omega will be equals to 3 QE over ml. So our final answer is 3 QE over ml. Got it? So here finding the best solution. So none of the above. None of these answer matches, since our answer is omega equals to under root of 3 QE over ml. Okay. Now moving towards our next question, that is question number 36. This question says that given below are two statements, one is labeled as assertion A and the other is labeled as reason R. Assertion A says that when you squeeze one end of a tube to get toothpaste out from the other end, Pascal's principle is observed. Okay, so assertion says that if we press from one side, the toothpaste get from the other side. Pascal's principle is observed, and the reason behind is that a change in the pressure applied to an enclosed incomposite transmitted undiminished to every portion of the fluid to the walls of the container. Okay, so these two statements are very true, since it is basically from the chapter Properties of Solids and Liquids. This question is from the chapter of Properties of Solids and Liquid, and it is basically the Pascal's principle. The Pascal's law says that whenever we apply pressure to a confined liquid, it is transmitted or distributed uniformly in all the directions. So if we squeeze one end of a tube, the toothpaste get out from the other end. So its correct answer is B. Both A and R are correct, and R is the correct explanation of A. Okay. Now, next question, question number 37. Okay, this question is directly from the electronics chapter. Okay, electronics chapter. This question says that a student is provided with a variable voltage V, a test resistor RT 10 ohm, two identical galvanometer G1 and G2, two additional resistor R1 10 milliohm and R2 0.001 ohm for conducting an experiment to verify Ohm's law. So we have to find the best suitable circuit for it. Okay. So student, first I'll draw one circuit and then I'll explain it. Okay. Sorry, if we look at the option B. Okay. Let us look at the option B. According to this, or according to the Ohm's law, whenever a resistor is placed in parallel to something, so it will be always a voltmeter. Always remember it, student. Whenever a resistor is placed in parallel to another galvanometer or resistor, it will always behave as a voltmeter. And whenever a resistor is placed in series to a galvanometer or a resistor or something, it will always act as a ammeter. Always remember it. So for voltmeter, the voltage should be, the resistance should be very higher. The resistance should be very high as compared to that of the ammeter. In our question also, R1 is 100 mega ohm, R1 is, sorry, 10 mega ohm, and R2 is 0.001 ohm. So R2 is very less as compared to R1. So our correct option is B. Got it? Always remember, whenever a resistor is connected in parallel to something, it will always acts as a voltmeter. Whenever a resistor is connected in parallel to something, it will always acts as a ammeter. Okay. Now, moving towards our next question, question number 38. It says that a body cools in 7 minutes from 60 degrees Celsius to what? 40 degrees Celsius. Okay. The temperature of the surrounding is 10 degrees Celsius. The temperature of the body after the next 7 minutes. So this is the question of Newton's law of cooling from the chapter thermodynamics. Newton's law of cooling. So according to this question, a body cools in 7 minutes from 60 degrees Celsius to 40 degrees Celsius. Means here T1 is 40 degrees Celsius and T2 is 60 degrees Celsius. The temperature of the surrounding Ts is 10 degrees Celsius. Okay. So after 7 minutes, we have to find the temperature of the body. So using the formula T2 minus T1 over T is equals to K, T1 plus T2 over 2 minus Ts. Okay. Now see carefully. 60 minus 40 over T. What is T? Time, 7 minutes, equals to K. K is unknown. T1 plus T2 over 2 minus surrounding temperature, 10 degrees Celsius. So it will be 20 over 7 equals to K. 100 by 2 minus 10, 250 So 20 over 7 equals to K, 50 minus 10, 40. So 2 2s are 4. So K will be equals to 1 by 14. Okay. Now it is saying that after 7 minutes, what will be the temperature? Okay. So after 7 minutes, the temperature will be, now T2 will be 40 and T1 we have to find. Okay. So again using the formula, T2 minus T1 over T equals to K. T1 plus T2 over 2 minus Ts. Surrounding temperature is 10. So 40 minus T1 over T7 equals to K1 by 14. 40 plus T, let us say T, okay, over 2 minus 10. So it will become 7 2s are 14. 40 minus T equals to 1 by 2. 40 plus T minus 20 over 2. So 40 minus T will be equals to 1 over 4. 20 plus T. So it will become 160 minus 40 equals to 20 plus T. 160 minus 20, it will be T plus 40. So 140 will be 5T. So T will be equals to 5 2s are 10, 5 8s are 40, 28. So our correct answer is D. Option D, 28 degrees Celsius. Got it? Okay, now next question. Question number 39. This question says that the energy density associated with electric field E and magnetic field B of an electromagnetic wave in free space is given by, simply it is asking for the formulas. This is from the chapter what electromagnetic waves. So the formula for it, electric field will be 1 by 2 epsilon naught E square, and for magnetic field, the formula is 1 by 2 mu naught B square. Simply, these are two formulas which we use in many numericals, and based on these two formulas in previous years also many questions has been asked. Okay, so our correct option is option A. Now, next question, question number 40. The weight of the body on the surface of the earth is 100 Newton. Okay. The gravitational force on it when taken at a height from the surface of the earth equal to 1/4 the radius of the earth is. Okay, this question is from the chapter gravitation. Now we'll understand this question and we'll solve it. The weight of the body on the surface of the earth is 100 Newton. Let us say on its surface, the weight is 100 Newton. Gravitational force on it when taken at a height from the surface of the earth. When it is taken at the height from the surface or equal to 1/4 of the radius. Let us say Earth's radius is R. When the height is 1/4 of the radius of the earth. At this height, we have to find the gravitational force, weight of the body. Okay. So now, answering this question, let the gravity formula is equals to Gm over R plus H whole square. Okay. Now, since it is saying that at height what? 1/4 of the radius. So, let us apply a trick multiplying numerator and denominator by R square. Okay. Since remember G is equals to Gm over R plus H square. Okay. Now this part Gm over R square is the, on earth when we are talking about the earth, the gravity formula is Gm over R square when we are talking on the surface of the earth. This formula G equals to Gm over R plus H, it is the formula which we'll be using when it is asked at some height, like in this question. Okay, so this gm over r square is for the surface of the earth. Okay, now multiplying both RHS and LHS by m, so we will get m considering is at z naught for the surface of the earth. Okay, z naught o into r square over r plus h whole square. Got it? Now mg, this is the weight, and now finding the weight at the height 1 by 4th part of the radius of the earth. It will be equals to mg naught, and in question the mg naught on the surface of the earth, mg naught is given as 100 Newton. Okay, so 100 Newton into r what? Radius of the earth. Okay, into r square over r plus h square. H is how much? R by 4 whole square. So 100 into r square over 5 over 4 whole square. Okay, now solving this question, 5r by 4. So it will be equals to 100 into r square over 25 over 16 r square. Cancelling r square, we get w is equals to 100 over 1 into 16 over 25. 25 into 4. So omega, weight is equals to 64 Newton. W weight is equals to 64 Newton. This is our final answer. So our next question, question number 41 says that the capacitor of capacitance 150 microfarad is connected to an alternating source of EMF given by E equals to 36 sine 120 pi t volt. The maximum value of current in the circuit is approximately equals to. So students, this question is from the chapter current electricity. Okay. Current electricity. So according to this question, capacitance is given C equals to 150 microfarad. It is connected to an alternating source of EMF. E is given 36 sine 120 pi t volt. E is equals to E naught sine omega t. Okay, since it is an EMF, we can consider it as voltage V equals to V naught sine omega t. So the maximum value of V naught is equals to 36 and omega is equals to 120 pi. How we find it? By comparing these two equations. Okay, now since we have to find the maximum value of current. So the peak value or the maximum value of current I naught, it is equals to V naught over reactance XC. Reactance is equals to 1 over omega C, V naught over 1 over omega C. Okay. So I naught will be equals to V naught into omega C. So here V naught is equals to 36 into omega equals to 120 into pi, and C is given as how much? 150 microfarad. 150 microfarad is equals to 150 into 10 to the power minus 6 farad. So it will be equals to 150 into 10 to the power minus 6. Now solving this, 36 into 120 into 3.14 into 150 into 10 to the power minus 6. It will be 36 into 12, 1010. So it will be 36 into 12. 432. So 432 into 3.14 4 2 8, 4 3 12, carry 1, 4 16, 1 17, 1 3 4, 6 10, 13, 8 4, 6 is 12, 13, 13 or 3, 16, 4 1 5 1 6, 1 3 6 6.48. So it will be into 3.14 into 15 into 10 to the power minus 6 plus 2. Okay. So these two will be 1366.48 into 15 into 10 to the power minus 4. So it will be 1366.48 into 15. Okay, 8 5 40, 5 4 24, 6 5 32, carry 3, 6 5 30, 33, carry 3, 5 3 15, 16 17 18, carry 1, 5 1 5 1 6. 4 6 6 3 1, 12 4 5 6 1 7, 6 3 9, 14, carry 1, 6 3 9 1 10. So it will become 20497.20 into 10 to the power minus 4. So it will be equals to 2.0497. Okay. So our correct answer is approx 2 ampere. Okay. 2.0497 ampere. Na? So the correct answer is 2 ampere. Now moving towards our next question. So the next question is, a 2-meter long scale with least count of 0.2 centimeter is used to measure the locations of object of an optical bench. So this question is directly from the optics. Got it? Now, while measuring the focal length of a convex lens, the object pin and the convex lens are placed at 80 centimeter mark and 1 meter mark, respectively. The image of the object pin and the other side of the lens coincides with image pin that is kept at 180 centimeter mark. Percentage error. We have to find the percentage error of the focal length. Okay. Students will understand this question as, let us say this is our convex lens. Okay. This is our object. Okay. So here given this is 80 centimeter. This 1 meter. What is 1 meter? This is object pin and the convex lens. 1 meter means 100 centimeter. And this is 180 centimeter. Okay. And its length is 2 meter and least count is 0.2 centimeter. Remember this, okay? Now, according to the given data, U will be equals to this 100 centimeter minus 80 centimeter. It will be 20 centimeter. In capital V will be equals to 180 minus 100 centimeter. It will be 80 centimeter, okay? Now, since we know the formula, 1 over F is equals to 1 over V, this basic formula, 1 over U. Or F will be equals to UV over U plus V. It will be equals to 20 into 80 over 20 plus 80. So F will be equals to 16 centimeter. Okay. Now, since it is asking to find the focal length, percentage error in estimation of the focal length. So, for percentage error or to find the error, 1 over F is equals to 1 over V plus 1 over U. Now, differentiating, we get minus del F over F square minus del V over V square minus del U over U square. Okay. Now, first calculate delta U and delta V. For calculating delta U and delta V, U will be equals to 100, the scale length, minus 80 plus minus the least count. Okay. So it will become 20 plus minus 0.4 centimeter. So here delta U is equals to 0.4 centimeter. And similarly, V will be equals to how much? 180 plus minus 2 minus 100 plus minus 0.2. It will be also 80 plus minus 0.4 centimeter, means delta V will be equals to 0.4 centimeter. Okay. Now, using the above formula, delta F over F square equals to delta V over V square plus delta U over U square. The percentage error can be found as delta F over F into 100. So, one F will go there. F delta V over V square plus delta U over U square. Okay. Now solving this, F is 16, 0.4 over V square plus 0.4 over 20 square. Since all are in centimeter, so simply solve it. 16 into 0.4, taking 20 common, 20 square, 1 over 4 square plus 1, so it will become 16 into 0.4 over 20 square into 16 plus 1, 17 over 16. So it will be equals to 17 into 0.4 over 400. Okay. So percentage error will be equals to how much? Delta F over F into 100. So it will be 17 into 0.4 over 400 into 100. Okay. So it will become 1.7 percentage error. So the correct option is this D, 1.70. Got it? Now next question. Next question, question number 43 says that figure shows a part of an electric circuit. The potentials at the point A, B, and C are 30 volt, 12 volt, and 2 volt respectively. The current through the 20 ohm resistor, we have to find the current passing through this resistor 20 ohm. Okay, this is from the chapter electric current, current electricity or electric current. Usually like current electricity, okay? This is from the chapter current electricity. Now, how will solve this? Let us consider this as the junction X, okay? Now, the potential of this junction X volt using the junction law. Junction law says that the current at any point X, let us say X, is the superposition of all the current, either emerging out or emerging in. Okay, means by using superposition theorem. Superposition theorem says that the current at any point is equals to algebraic sum of all the current emerging away from it or emerging towards it. Means suppose the current is, let us say this is I1, this is I2, this is I3. So the current at point X or the potential at point X will be equals to, current will be I1 plus I2 plus I3 equals to 0. Algebraic sum of all the current. Got it? So at point X, using superposition theorem, the sum of all current will be equals to 0. This superposition theorem, according to superposition theorem. So the potential from the Ohm's law, V equals to IR, potential equals to current into resistance. So current into resistance. So current will be equals to potential over resistance. Okay, so I1 plus I2 plus I3 equals to 0 from superposition theorem. So I1 will be equals to this X minus here 30 volt, here 12 volt, and in here C 2 volt. So X minus 30 over 10. I1 will be equals to X minus 30 over 10 plus I2. I2 will be equals to X minus 12 over this 20. X minus 12 over this 20 plus I3. I3 is equals to this X minus 2 over this 30. X minus 2 over this 30, this will be equals to 0. Now solving this equation, 1 over 60, it equals to 6x minus 180 plus 3x minus 36 plus 2x minus 4. It will be equals to 0. So 1 over 60, 11x minus 220 is equals to 0. So x will be equals to 220 over 11. It will be equals to 20 volt. Now it is asking about the current through 20 ohm resistor. So current through 20 ohm resistor will be equals to what? I2 will be equals to x minus 12 over 20. So I2 will be equals to x minus 12 over 20, and the value of x is what? 20. So 20 minus 12 over 20 equals to how much? 8 over 20. It will be equals to 0.4 ampere. So I2 means current passing through the 20 ohm resistor is how much? 0.4. So the correct option is 0.4. Got it? Now, our next question, question number 44. It says that a small particle of mass m moves in such a way that its potential energy given. Potential energy is this much. U is equals to 1 by 2 m omega square r square, where omega is constant and r is the distance of the particle from the origin. A particle is moving in such a way. Okay. Assuming Bohr's quantization of momentum and circular orbit, the radius of nth orbit will be proportional to. We have to find the radius of the nth orbit. Okay. Given potential energy, U is equals to 1 by 2 m omega square r square. Okay. This is from the atomic and nuclear physics chapter. Atomic and nuclear physics chapter. Okay. So U is equals to 1 by 2 m omega square over r into r square. Since force is equals to minus del U over del r, so F will be equals to minus 1 by 2 m omega square into 2r. So F will be equals to minus m omega square into r. Negative sign here. Negative sign indicates that the force is towards inward force. Okay. F is towards the center. Force is towards center means inward force. Now, using Bohr's quantization of angular momentum. Bohr's quantization of angular momentum says that whenever an electron is revolving around its orbit, its angular momentum is equals to L will be equals to always equals to NH over 2 pi. Okay, means L MVR will be equals to NH over 2 pi. Got it? Okay, so here F will be equals to m omega square into r. Also, F equals to mv square over r equals to using only magnitude m omega square r. So mv square equals to m omega square into r square. Got it? Cancelling m. So v square is equals to omega square into r square. So v will be equals to under root of omega square into r square, means v equals to omega r, putting this value of v here. So m into v omega r into r equals to nh over 2 pi. So this we have to find the relation between radius of nth orbit. Radius and n. So r square is equals to n. So r will be equals to under root of n. So the correct answer is D. R is equals to under root of n. Okay. Now next question. Moving towards the next question. The next question says that given below are two statements, one is labeled as assertion and other is labeled as reason. Assertion A. Diffusion current in a PN junction is greater than the drift current in magnitude if the junction is forward biased. And reason given for this statement is diffusion current in a PN junction is from the N side to the P side if the junction is forward biased. Okay. So let us assume this is PN junction semiconductor devices. This is question is from the chapter of electronic device. Okay. From the chapter of electronic device. We are given PN junction. So in PN junction, basically in forward bias, when the electron moves from N type to P type, means from N diode to P diode, so the drift current moves from the P junction P to N. Electrons are moving from N to P, so the drift current is moving from P to N. Okay. Diffusion current is greater than the drift current. It is correct since the drift current is always in units of milliampere. So the diffusion current in a PN junction is greater than drift current. And reason is given key diffusion current in a PN junction is from N side to P side if the junction is forward biased. But this reason is wrong because if the electrons are moving from N to P, so the current will move from P to N, okay? Not from N to P side. The current will move from P side to N side. So the correct option is C, that is both A and R are correct, but R is not the correct explanation of the A. Got it? Now moving towards our next question, that is question number 46. Choose the incorrect statement from the following. So the first statement is the linear speed of a planet revolving around the sun remains constant. The linear speed of a planet revolving around the sun remains constant. Since the planet revolves around the sun in an elliptical orbit, its linear speed is not constant. Linear speed cannot be constant since the planets are revolving around the sun in an elliptical orbit. So its speed cannot be constant. So this statement is not correct. This is the incorrect statement. Second statement says that the speed of satellite in a given circular orbit remains constant. Very true. Since a satellite is moving in the orbit, its speed will always remains constant. When a body falls towards Earth, the displacement of the Earth towards the body is negligible. It's very true. It is true. For a planet revolving around the sun in an elliptical orbit, the total energy of the planet remains constant. This is very true. Okay, from this energy, from this statement, always from the total energy statement, we get the formula for angular momentum, that is mvr equals to nh over 2 pi. This is quantization of angular momentum, or we can say that Bohr's quantization. So this question is basically from atomic nuclei model. Means this is from the atomic and nuclear part physics, okay, modern physics. So moving towards our next question, question number 47. This question is states that a child of mass 5 kg is going round a merry-go-round that makes one rotation in 3.14 seconds. The radius of merry-go-round is 2 meters. The centrifugal force, this is very simple question. We have to find the centrifugal force. Simply the formula for centrifugal force is F equals to m omega square r. Okay. So there is a merry-go-round. A child is moving in a merry-go-round. And here given that mass m is 5 kg. One rotation in 3.14 second. It is making one rotation in how much? time 3.14 second. Okay. So omega is basically the angular frequency. How we find the angular frequency? In terms of radian per second, since it is completing one rotation, means 2 pi per second. Okay. 2 pi per second. Per second means time. How much time? Pi 3.14, the cancelling, so we get omega equals to 2. So here centrifugal force F will be equals to mass. Mass is given as 5 kg into omega square. 2 square into R. R will be 2 meter. 2. So this will be equals to 40 Newton. So F will be equals to 40 Newton. So the correct option is option A. That is F will be equals to 40 Newton. Okay. Now moving towards our next question. Question number 48. This question says that as shown in figure, a particle is moving with a constant speed pi m per second. So means speed is given as pi meter per second. Okay, considering its motion from A to B. A to B, the magnitude of the average velocity. Students, champs, we have to find the average velocity. Okay, now understanding this question as, let us say, this is our circular motion. A body is moving, let us say, from point A to point B with a velocity V. Let us say the body is moving from point A to B with a velocity V. Okay. And as shown in the figure, from point A to B, it is making an angle of 120 degrees. So it is making an angle, let us say it is making an angle of 120 degree. Okay. We have to find the average velocity. The average velocity will be displacement over time. Okay, so first we have to find the displacement. We have to find this distance from point A to point B. How we can find this displacement? Let us say this is angle 60 degree. The whole angle is 120, na? So this will be 60 and this will be 60. So using the formula for sine 60. Sine 60. So this will become how much? How much? Let us say it will become sine 60 into R, and this will also sine 60 into R. So it will become root 3 by 2R. It will also become root 3 by 2R. The whole displacement A to B, from A to B, it will become 2 into root 3 by 2R. So it will be equals to root 3R. So average velocity, V average will be equals to displacement over time, means root 3 by 3R over time. Over time, okay? So time will be equals to displacement over velocity, distance over velocity, or displacement over velocity. So here time will be equals to distance. This is circumference, means this is 2 pi r. This is 1/3 part, means displacement how much? 2 pi r by 3 into velocity. Velocity v. Now putting this value of v here. So v average will be displacement over time. Displacement is root 3r and time is 2 pi r over 3v. Means r cancel. So v average will be equals to root 3 over 2 pi into 3v. So we get v average is equals to 3 by 2 into what? Root 3 into v over pi. Since this v is equals to pi meter per second, so putting the value of v here, so v average will be equals to 3 by 2 into root 3 into pi over pi. Pi cancels out each other. So V average will be equal to 3 by 2, 1.5 into root 3 meter per second. So this is our final answer. V average will be equals to 1.5 into root 3 meter per second. So the correct option is option D. Okay. Got it? Now moving towards our next question. Question number 49. According to this question, the work functions of aluminium and gold are 4.1 electron volt and 5.1 electron volt respectively. The ratio of the slope of stopping potential versus frequency plot for gold to that of aluminium is. First of all, student, this question is directly from the chapter Dual Nature of Matter and Radiation. This is basically from the topic of photoelectric effect. You know what is photoelectric effect? When the photon of a certain particular frequency incident on the surface of a metal, it ejects out electron from it. According to this ejection of the electron, EV naught, maximum kinetic energy will be equals to EV naught equals to initial kinetic energy minus phi, where phi is the work function. So EV naught will be equals to H into F, Planck's constant into frequency, minus phi work function. So V naught will be equals to H over E into F minus phi over E. This H over E is basically the slope, and this slope will be same for aluminum as well as for the gold. So the ratio of their slope means ratio of the slope for aluminum and for the gold will be 1 over 1 means, so the correct answer will be A1. Okay, since the slope m will be same for all the graphs and it will be independent of this phi. Okay, so next question, question number 50. A particle starts with an initial velocity 10 meter per second, means we are given u is equals to 10 meter per second along the x direction and accelerate uniformly at the rate of 2 meter per second, means acceleration is given 2 meter per second square. The time taken by the particle to reach the velocity of 60 meter per second, v, is 60 meter per second. Okay, this is from the equations of motion. There are three equations of motion. We will use the first equation of motion, that is v minus u is equals to at. This is our first equation of motion. So it is asking for what? Time. So student, this is very simple question. Only you have to use the formula. So T will be equals to V minus U over A. It will be 60 minus 10 over 2. 50 by 2, it will be equals to, T will be equals to 25 seconds. This is very simple question. So T is 25 seconds. So the correct answer is C, 25 seconds. So students, now starting with question number 51. The question number 51 says that a simple pendulum with length 100 centimeter and bob of mass 250 gram is executing simple harmonic motion of amplitude 10 centimeter. The maximum tension in the string is found to be x over 40 Newton. The value of x is, so we have to find the value of x. First of all, this question belongs to the chapter of oscillations and waves. Okay. This question belongs to chapter oscillation and waves. It is question of simple pendulum. So first of all, we should know what is simple pendulum. Suppose this is a string. This is attached to this support and a bob is attached to it. Suppose the length of this string is L and the mass of this bob is M. This bob is doing 2 and 4th motion. This motion is the simple harmonic motion. It is going back and forth. So this is performing simple harmonic motion. So this is our basic simple pendulum. Okay. Simple pendulum. According to this question, the length L of this string is 100 centimeter and the mass of the bob is 250 gram. Okay, it is performing simple harmonic motion and its amplitude A is 10 centimeter. Okay. So the maximum tension in the string is found to be this. We have to find this value of x. So for a simple pendulum, the maximum tension is equals to gravitational weight mg force plus upward force mv square over L. Since the length of the string is L, mv square over L. Now, here given mass equals to 1 by 4 kg, L is equals to 1 meter, G is equals to gravitational force 9.8 meter per second square. And amplitude is 10 centimeter, that is 1 over 10 meter. Now, for simple harmonic motion, the kinetic energy, maximum kinetic energy will be equals to half mv square. It will be equals to half m omega square over a square. Since v equals to r omega and here a is the amplitude, so v equals to a into omega. Okay. So where and omega is equals to under root g over L, as we all know. So mv square is equals to m under root g over L whole square into a square. So mv square becomes mg a square over L. Now putting this value of mv square from equation 1 in this equation. Okay. So T maximum means tension will be equals to mg plus mg a square over L square. Taking mg common, 1 plus a square over L square, it will be equals to mg 1 plus 1 over 10 square. Okay. So it will be equals to 1 over 4 into gravity 9.8 into 101 over 100. Okay. So T maximum will become, solving this, 98.98 over 40. So comparing this T maximum with the value given in the question, what? X over 40 Newton. So it will be equals to X over 40. So X will be equals to 98.98. That is 99. Okay. So the value of X is 99. Got it? Now, the next question is, experimentally, it is found that 12.8 electron volt energy is required to separate a hydrogen atom into a proton and an electron. Energy, 12.8 electron volt energy is required to separate hydrogen atom. Hydrogen atom 1H1, 1 proton plus 1 electron. Okay. So orbital radius of the electron in a hydrogen atom is this, the value of X. Radius 9 over X into 10 to the power minus 10 meter. Okay. So this question is from the chapter Atomic and Nuclear Physics. Okay. So it is saying that there is one hydrogen atom, and to separate this hydrogen atom into one proton and one electron, 12.8 electron volt energy is required. And its orbital radius is this. We have to find the value of this X. Okay. Since energy formula, the simplest energy formula is 1 by 2 K E square over R, where the value of K is K 1 over 4 pi epsilon naught. Its value is 9 into 10 to the power 9 Newton meter square over C square as given in your question. Okay. Now, from here, this R will become R is equals to K E square over 2E. Value of E is 12.8 electron volt. Okay. Converting this electron volt into joule. Okay. Converting this electron volt into joule, we get 12.8 into 1.6 into 10 to the power minus 19 joule. Okay. From here, 1 electron volt equals to 1.6 into 10 to the power 90 minus 19 joule. So we write in place of electron volt 1.6 into 10 to the power minus 19 joule, and this 1.6 into 10 to the power 19 is equals to 1 electronic charge. So in place of this, we can write it as 12.8 E joule. Got it? So R will become 9 into 10 to the power 9 E square over 2 into 12.8 E. This E cancels out. So R will become 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 over 2 into 12.8. Now solving this, we get 9 into 1.6 into 10 to the power minus 19 plus 9 over 2 into 12.8. Now solving it, we get 2 6 is 12, 2 4 is 8, 8 8 is 64. So 9 over 8 to 16 into 10 to the power minus 10. Okay. So comparing this with the given equation, 9 over x into 10 to the power minus 10. So 9 over 16 into 10 to the power minus 10 equals to 9 over x into 10 to the power minus 10. So the value of x is 16. X will be 16. This is our final answer. Got it? Yeah. Now moving towards next question. Question number 53. This question says that a beam of light consisting of two wavelengths, 7000 angstrom and 500 angstrom, is used to obtain interference pattern in Young's double slit experiment. So this question is from the chapter of wave optics. Okay. Double slit experiment. The distance between the slit is 2.5 millimeter and the distance between the place of the slits and screen is 150 centimeter. The least distance from the central fringe where the bright fringes due to both the wavelength coincide is this. We have to find the value of n. So first of all, we should know what is Young's double slit experiment. Means there is a source S. A light wave is coming from this source. It is a coherence light. Always remember, for Young's double slit experiment, the light should be coherent. Okay. Coherent light is coming. It is incident on different slit, like this is slit 1 S1, this is slit S2. Okay. And wave fronts are emerging from it. So from these two slits, different wave fronts are emerging, and there is a screen S dash, and we are getting central bright fringe, different fringes. The central one is bright. We are getting bright fringes or fringes of alternating minimum intensities and maximum intensity. So we are getting different bright and dark fringes. The central one is the bright one, and alternating one will be dark and bright, dark and bright, dark and bright. Okay. So the light is consisting of two wavelength of 7000 angstrom and 55 angstrom. The distance between the slit is 2.5 mm. Let us say the distance between this slit S1 and this slit S2 is 2.5 mm. And the distance between this slit and this screen is 150 centimeter. Okay. The least distance from the central fringe, this is our central fringe, where the bright fringes are formed, is this. So we have to find the value of this n. Okay. Now let us say N1 maxima of 7000 angstrom coincides with N2 maxima of 5500 angstrom. Let us say that. Okay. Now from therefore N1 beta 1 is equals to N2 beta 2. Therefore N1 over N2 will be equals to lambda 2 over lambda 1. It will be equals to 5500 over 7000. It means 11 over 14. Okay. It means that 11th maxima of 7000 angstrom coincide with 14th maxima of 5500 angstrom. Okay. Now we have to find the what? We have to find the least distance from the central fringe where the bright fringes due to both the wavelength coincide. Means this wavelength and this wavelength, the bright fringes of both the wavelength coincide. So we have to find the least distance of the central fringe. So to find the least distance, let us say y is equals to n1 beta 1. So y will be equals to n1 lambda 1 d over d. Okay. So it will be equals to 11 into 7000 into 10 to the power minus 10 into 150 into 10 to the power minus 2 over d, the distance 2.5 into 10 to the power minus 3. So solving this, we get 11 into 7 into 5 over 2.5 into 10 to the power minus 5 meter. Therefore, y will be equals to 462 into 10 to the power minus 5 meter. So comparing this with this, n into 10 to the power minus 5 meter, n into 10 to the power minus 5 meter, we get n equals to 462. This is our answer. Got it? Yeah. So moving towards next question, question number 54. Two concentric circular coils with radii 1 centimeter and 1000 centimeter and the number of turns are 10 and 200 respectively are placed coaxially with centers coinciding. The mutual inductance, it is asking for the mutual inductance. Okay. So now let us say we have two circular coils. This is A and this is B. Let us say N1 be the number of turns in A. This is 1 and 2. And 2 be the number of turns in circular coil 2. Okay. Let us say current I is flowing in this circular coil. Okay. Circular coil 2. Okay. Now let us say its radius is R1, its radius is R2. So the magnetic flux phi due to coil 2 in coil 1 will be equals to N1 BA. Okay. It will be equals to N1 into B mu naught I over 2R2 due to 2 into 1 na, over 2R2 into area pi R square pi into R1 square. So phi. So mutual inductance M will be equals to what? Mutual inductance and M will be equals to everything except I. It will be N1 mu naught over 2R2 into pi R1 square. Just put the numerical values in this expression and we will get our desired answer. The mutual inductance M will become N1. N1 is how much? 10. Okay. 10 into 4 mu naught. Mu naught is 4 pi into 10 to the power minus 7 into pi into R1 square. R1 is 1 centimeter. So it will be 10 to the power minus 4 meter divided by 2 into R2. R2 is 1000 centimeter. So it will be 1000 into 10 to the power minus 2 meter. So it will become 4 pi square into 10 to the power minus 9. So mutual inductance M will be equals to 4. Here pi square is 10. So putting the value of pi square as 10 into 10 to the power minus 9, it is equals to 4 into 10 to the power minus 8. So our mutual inductance M becomes 4 into 10 to the power minus 8. Okay, 4 Henry. Got it? Now, next question, question number 55. As shown in figure, two parallel plate capacitors having equal plate area of 200 centimeters square are joined in such a way that A is not equal to B. The equivalent capacitance of the combination is X epsilon naught F farad. The value of X, we have to find this value of X. So we are given two capacitors A and B. Since these two capacitors are connected in series, these are in series. Okay. It is dealing with the capacitor. So this question is from the chapter, capacitance chapter, electrostatics. Okay. Now, since these two capacitors are in what series, so equivalent capacitance will be, for series the formula is 1 over C equivalent is equals to 1 over C1 plus 1 over C2. Okay. So C, formula for the capacitance is C is equals to epsilon naught A over D. D is the distance. So 1 over C equivalent will become 1 over epsilon naught A into this A plus epsilon naught A into this B. So 1 over C equivalent will be equals to A plus B epsilon naught A. This implies that C equivalent will be equals to epsilon naught A over A plus B. Okay. Now this A plus B will be equals to this 5 millimeter minus this 1 millimeter. Okay. A plus B will be equals to 5 minus 1 equals to 4 millimeter. Now C equivalent will be equals to epsilon naught into A. A is the area. Area is 200 centimeters square. So 200 into 10 to the power minus 4 over A plus B. 4 millimeter. 4 into 10 to the power minus 3 meter. Solving it, we get epsilon naught into 50 into 10 to the power minus 4 plus 3. It will be equals to epsilon naught into 50 into 10 to the power minus 1. So C epsilon equivalent will be equals to what? X epsilon naught F na. Comparing it with X epsilon naught. So it will be equals to 50 into 10 to the power minus 1 means 5 epsilon naught. So X epsilon naught will be equals to 5 epsilon naught. So the value of X will be 5. Okay. Yeah. So moving on, next question. Question number 56. A proton with a kinetic energy of 2 electron volt moves in a region of uniform magnetic field of magnitude pi by 2 into 10 to the power minus 3 Tesla. Okay. The angle between the direction of magnetic field and the velocity of proton is 60 degree. The pitch of the helical path taken by the proton is, we have to find the pitch of the helical path. This is from the electrostats. So, okay, now let us understand this question. It is saying that a proton with a kinetic energy of 2 electron volt, given kinetic energy is 2 electron volt, moves in a region of uniform electric field of magnitude B, magnetic field pi by 2 into 10 to the power minus 3 Tesla. The angle between the direction of the, let us say the magnetic field is in this direction. So the angle between the direction of magnetic field and the velocity v of the proton is 60 degree. Got it? Angle between magnetic field and velocity is 60 degree. The pitch of the helical path taken by the proton. We have to find the pitch of the helical path. Okay. First of all, the magnetic field B is given as pi by 2 into 10 to the power minus 3. And kinetic energy is given 2 electron volt. We know that kinetic energy is equals to half mv square. So V will be equals to under root 2 into kinetic energy over m. Okay. Now the formula for pitch. Pitch will be equals to C. This will be resolving into 2. This will be cos term. This will be sine term. Okay. V cos theta, V sine theta. So this will be V cos theta is what? 60 degree into time period of 1 rotation. Okay. Time period of 1 rotation. So pitch will be equals to V cos theta into T. It will be so equals to V cos 60. And see T formula 2 pi m over EB. Got it? So it will be equals to under root of 2 into 2 into 1.6 into 10 to the power minus 19 over 1.6 into 10 to the power minus 27. This is V. 2 ke over m. 2 ke over m. Okay. 2 into k into e. 2 ke, sorry. 2 ke, 2 electron volt. Converting this electron volt into joule over m. M is 1.6 into 10 to the power minus 27 kg. Okay. Into cos 60 into 2 pi m upon EB. 2 pi m. 1.6 into 10 to the power minus 27 over EB. 1.6 into 10 to the power minus 19 into B, given as pi by 2 into 10 to the power minus 3. Now solving this equation, we get 2 into 10 to the power 4 into 1 by 2 into 4 into 10 to the power minus 5. It will be equals to 4 into 10 to the power minus 1 meter equals to 40 centimeter. So our final answer is 40 centimeter. Okay. This is the formula. Now moving towards our next question. A body is dropped on the ground from a height h1 and after hitting the ground, it rebounds to a height h2. If the ratio of velocities of the body just before and after hitting ground is 4, the percentage loss in kinetic energy is x by 4. We have to find the value of x. Okay. According to question, let us try to understand this question. According to this question, suppose this is the ground. Okay. At first, a body is dropped from a height h1 and after hitting the ground, it rebounds to a height h2. Okay. If the ratio of the velocities of the body just before and after hitting the ground is 4, when it hits the ground, let us say the ratio of just before and after. So it is hitting with a velocity of 4v and after it gets v. Okay. When it hits the ground, it is of velocity 4v and after hitting it is going back with the velocity of v. We have to find the loss in the percentage loss in the kinetic energy of the body is x by 4. We have to find this value of x. Okay. So as we know that the kinetic energy is equals to half mv square. mv square. Okay. So kinetic energy starting, it is 1 by 2. So it is directly proportional to v square, na, basically. So at starting, before hitting, kinetic energy is directly proportional to 4v square. Means in starting it is 16v square, and after hitting, when it goes back, it is of v square only. Okay. Means so percentage loss in kinetic energy will be equals to del Ke over original Ke into 100. It will be 16. Let us say K, 16K minus K over 16K into 100. Okay. 15K over 16K into 100. So 15 over 16 into 100. It will be equals to how much? 375. Got it? So percentage kinetic energy over Ke into 100 will be equals to 375. Got it? Okay, now moving towards our next question. Question number 58. A ring and a solid sphere rotating about an axis passing through their centers have same radii of gyration. The axis of rotation is perpendicular to the plane of ring. The ratio of radius of ring to that of the sphere is this. The value, we have to find the value of what x. This question is from the chapter of rotational motion. It is saying that there is a ring and a solid sphere. Okay. Rotating about an axis, passing through their centers, having same radii. Both are having same radii. R1, R2. R1 is equals to R2. Radii of gyration. The axis of rotation is perpendicular to the plane of ring. Okay. So the ratio of radius of ring to that of the sphere. First of all, the formula for radius of gyration. The formula for radius of gyration is equals to under root of moment of inertia over mass. Okay. Let us say GR for ring, it will be equals to IR over MR. Okay. And GS solid sphere will be equals to IS over MS. Now, since they are having same masses, so this simply depends upon under root of IR. Okay. So formula for the moment of inertia equals to MR square GR, na? Okay. So GR over GS will be equals to under root of IS over MS. GR will be equals to GR over GS will be equals to a ring MR square under root of MR square over what GS, it will be equals to under root of 2 by 5 MR square. So solving this, we get GR over GS equals to under root of 2 by 5. So comparing it with this, we get is equals to under root of 2 of x. X will be equals to 5. Got it? Now, moving on, question number 59. In question 59, it says that as shown in figure, the voltmeter reads 2 volt across 5 ohms resistor. The resistance of the voltmeter. Okay. Since it is saying that the 5 ohm resistor has how much reading? 2 volt reading. If it is having 2 volt reading, so it will be of 1 volt. Here will be 1 volt. Okay. Because this 3 volt and 1 volt makes this 2 volt. Na? So if it's having 5 ohm resistor having 2 volt reading, so this must be of 1 volt. If this is of 1 volt, using Ohm's law, V equals to IR. So current through this resistor, I will be equals to V over R, 1 over 2 equals to 0.5 ampere. Since the current is flowing in this direction, so this will also have 0.5 ampere. Let us say the resistance through this voltmeter is R. Let us say, okay. So through this, current will be equals to EMF over R. Current is how much? 0.5 means 1 by 2 equals to EMF 3 volt over R. R is this and this are in series, but these two are in parallel. So we have to solve this. Okay. For solving this, we like 2 plus solving first this 1 over 5 plus 1 over R is equals to 1 over R is equals to 1 over 5 plus this 1 over R. 1 over R dash is equals to like 5R, 5 plus R. So this R dash will be equals to 5R plus, since these two are in parallel, but these two are in series. So first we have to solve this parallel one, then it should be arranged in series with this. So 2 plus 5R over 5 plus R. Okay. So I becomes 3 over 2 plus 5R over 5 plus R. Okay. The resistance of the voltmeter. We have to find the resistance of the voltmeter. This I is 1 by 2. Solving this whole equation, we get 3 is into 2 equals to 2 plus 5R over 5 plus R. So 3 into 2, 6 equals to 2 into 5 plus R plus 5R over 5 plus R. Now multiplying this 5 by R with 6, 10 plus 2R plus 5R. 30 plus 6R equals to 10 plus 7R. 20 equals to 7R minus 6R R. So the value of R is 20. Okay. The value of this R is 20. So got it? Now going towards our next question, question number 60. This question says that a metal block of mass m is suspended from a rigid support through a metal wire of diameter 14 millimeter. The tensile stress developed in the wire under an equilibrium state is this 7 into 10 to the power 5 Newton per meter square. The value of mass m. Okay. So this question is directly from the chapter of properties of solids and liquids. So as we know that the simple formula using stress formula, okay? Force over area. Force is mg over area is A. Okay. So we have to find the value of this m. Okay. So m will be equals to this stress into A over G. Stress is given 7 into 10 to the power 5. Area is pi r square, diameter 14 millimeter, means radius 7 millimeter into pi r square over G, gravity 9.8. So M will be equals to 7 into 10 to the power 5 into pi 22 by 7. As it is saying to use pi equals 22 by 7 and G 9.8 meter per second square into R 7 into 10 to the power minus 3 meter whole square over G 9.8. So solving this, we get M is equals to 10 to the power 5 into 22 into 7 whole square 749 into 10 to the power 3 to 6 plus 5 over 9.8. Okay, solving this we get minus 1 plus 5, 11 kg. So M will be equals to 11 kg. So our mass is 11 kg. Got it? This is our final answer.